Hello everyone, welcome to lecture on numericals on DC machine. So let us discuss the few numericals related to the DC machine, one numerical related to DC generator and one more numerical related to the DC motor. So let us discuss the numericals. Let us read out the given numerical. An 8-pole DC generator has 500 armature conductors and has useful flux per pole is 0.065 Webers. What will be EMF generated if it is lap connected and runs at 1000 rpm, and what must be speed at which it is to be driven to produce the same EMF if it is wave connected. So first, to solve this, let us write down the given data. The given data for the machine is, it is 8-pole, number of conductors directly given here, it is 500. Okay, flux is given, it is useful flux 0.065 Webers. So these are the data given. What will be, this is the generator details, what will be EMF generated if it is lap connected and runs at 1000 rpm. So first question is EMF generated. What is the EMF generated? First question is, what is the EMF generated if the generator is lap connected? We know that for lap connection A is equal to P, which is equal to 8, and when the generator runs at 1000 rpm. So here we know the equation Eg is equal to generated EMF for the DC generator is 5ZNP by 60A, 5ZNP by 60A. This is the formula. So in this equation, phi is given, Z is given, speed is given, number of poles are given. So A is also given. For lap winding, it is A equal to P. So if you substitute all the values, it is 0.065 Webers into number of conductors or 500 into speed 1000 rpm into number of poles 8 divided by 60 into 8. So answer is, if you calculate this, you will get this as 541.67 volts. So this is the EMF generated if the given DC generator is lap connected and runs at 1000 rpm. Now to produce the same EMF, that is the generated voltage of 541.67 volts, to produce the same voltage, what must be the speed at which the motor is to be driven? So to produce the same voltage, you need to find out what is the speed at which the generator is driven if the winding is connected in wave mode, if the winding is wave connected. So let us understand this. The generated EMF here remains same. That is 541.67 volts. So for the same generator, if instead of lap connected, if it is wave connected, then the number of parallel paths for wave connected is equal to 2. We know this 2. For lap connected, it is equal to P. Now we need to find out at which speed the generator is to be driven to produce the same EMF. So again we need to use the same equation. Eg is equal to 5ZNP by 60A. Now we need to produce the same voltage, so Eg we need to take it as the same, that is 541.67. For a DC machine, the flux is already given, DC generator, number of conductors also given, number of poles also given, and the number of parallel paths. Since now it is wave connected, so A will be equal to 2. So only unknown is we need to find out the N here. So N we need to find. So if you equate N is equal to it is Eg 60A divided by 5Z P. So upon substituting all the values, we will get this speed as Eg is 541.67 into 60 into number of parallel paths are 2 divided by this is 0.065 I think into number of conductors are 500 into number of poles are 8. So upon calculating this, you will get this as 250 RPM. So in case of the here you can observe lap winding and wave winding connection. If you want the same voltage to be maintained in wave winding also, then the speed at which the generator to be driven is reduces by 1/4, that is it became 250 rotations per minute, whereas in case of the lap connected, the speed was 1000 RPM. So this is the solution of the given problem. We will now move on to the next problem, that is based on the DC motor, particularly it is DC shunt motor. Second problem. So let us read out the problem and understand what are the given quantities and what are the quantities to be calculated. Okay. So a 200 volts 4-pole lap wound DC shunt motor has 800 conductors on its armature. The resistance of armature winding is 0.5 ohms and that of shunt field winding is 200 ohms. The motor takes 21 amps and flux per pole is 30 milliwebers. Find speed and gross torque developed in the motor. So let us understand, there is a DC shunt motor. There is a DC shunt motor where the number of conductors in the DC shunt motor, that is in the armature, are given. It is 800. This is the DC shunt motor. Okay, this DC shunt motor is the applied voltage to this DC shunt motor is 200 volts. In this data is given a 200 volts 4-pole lap wound DC shunt motor has 800 conductors. So given voltage is the applied voltage, that is V is equal to 200 volts. Now number of poles are given, it is 4. Since it is given as lap winding, it is A is equal to P is equal to again 4. Number of conductors Z is equal to 800 and flux per pole is also given, it is 30 milli means 10 power minus 3, 30 milliwebers, and motor takes a current of 21 amps. So here we need to understand motor means it is whole thing, it includes armature and the field winding. So this motor takes a current, this current is nothing but the load current. So load current is given, load current is 21 amps. So these are the data given. Here we need to find out the speed of the armature, that is speed of the motor, and the torque developed in the motor, that is one is N we need to find out, and one more is the torque TA we need to find out. So these are the two unknown quantities we need to find out. So to find out the speed, we need to use the equation, that is we have the speed relation from the only one equation, that is Eg is equal to, sorry, it is a motor, so in case of motor it is back EMF EB. So EB equal to 5Z NP by 60A. So to find this speed, the flux is given already, number of conductors given, P is given, A is given, but EB, back EMF, is not given. For DC shunt motor, back EMF EB is not given. So we need to find out the back EMF here from the other given data. And as well, the armature winding resistance and shunt field winding resistance are also given. RA is equal to 0.5 ohms. Shunt field winding resistance RSH is equal to 200 ohms. So to calculate the back EMF, let us apply KVL here. Upon applying KVL, we know the equation V minus EB, that is back EMF, V minus EB equal to IA RA. So V is already given, RA is given, but IA is also unknown. To calculate the IA, we need to the relation between IA, IL and ISH for a shunt motor. IA, IL and ISH is IL is equal to, load current is equal to armature current plus the shunt field winding current. Here IL is known but ISH is not known. So to calculate ISH, we know the relation V is equal to, simple, it is ISH into RSH. So RSH is known, V is known. So let us calculate the ISH. So if you calculate ISH is equal to V by RSH. V is 200, RSH is again 200. So ISH will be 1 amps. So ISH is 1 amps. We know IL is equal to IA plus ISH. So IA is equal to IL minus ISH. So this will be 21 minus 1 is equal to 20 amps. So IA is 20 amps here. Let us calculate the back EMF, that is back EMF is equal to now V minus IA RA. V minus IA RA. V is given, it is 200, minus IA is 20 into RA is, it is given 0.5. So this will be, upon calculating this, you will get this as 190 volts. So the back EMF is 190 volts. From this we can calculate N is equal to, it is EB 60A, upon rewriting N is equal to EB 60A by 5ZP. So this, upon substituting all the values, it is 190 into 60 into number of parallel paths are equal to poles P, that is 4, 5 is 30 milli into 10 power minus 3 into number of conductors are 800 into number of poles are again 4. So the answer is, the speed, upon calculating this, you will get this as 475 RPM, rotations per minute. So this is the speed of the DC shunt motor. Now we need to find out the one more quantity, that is torque developed, that is TA, torque developed. TA is equal to, we know the formula, that is TA is equal to 0.159 into IA into flux into P into Z divided by A. So by using this equation we can directly calculate the torque developed, 0.159. IA we have calculated, it is 20 amps, and flux is 30 milli, 30 into 10 power minus 3. Number of poles are 4, number of conductors are 800 divided by the number of parallel paths, again equal to, since it is a lap connected, equal to P is 4. So upon calculating this, the torque developed in the armature of the DC shunt motor is 76.32 Newton meter. So this is the torque developed in the DC shunt motor. So this is the solution of the given problem. So any problem in DC machines depends only on two equations. One is generated equation in case of the generator. In case of motor, it is the same equation will be back EMF. And in motor we have one more equation, that is torque equation, and depending on the given DC machine, either it may be a shunt machine, series machine, for the respective machines we need to write the equations, then you can easily solve the given numericals. Thank you.